Hello everyone. My name is Abualkasim Bakir. I would like to introduce my research article about short-circuit fault detection and remedial in full bridge rectifier of series resonant DC-DC converter based on inductor voltage signature. The complete list of the author are Abualkasim Bakir and Andrii Chub and Dmitri Vinnikov from Tallinn University of Technology, Estonia. My presentation outline will be start with a short introduction about the importance of fault tolerant research topic, and then we'll show the study topology based on the series resonant DC-DC converter, and next I will show the proposed fault diagnosis and detection method, and the proposed fault tolerant technique to keep keep the converter continued its operation post the fault occurrence, and later the simulation results are given at two cases, at light load case and full load case, and at final the conclusion and the future work are given. Why we need the fault tolerance? Uh, if we have a converter, for example, connected to connect PV to load, it contains some passive element and consists of power devices and diode. This component maybe have a failure or a fault, which could be either open circuit fault or short circuit fault. The power switches are considered the most prominent source of semiconductor fault due to thermal and electrical stress. So it is important to deal with the fault tolerance, and the fault diagnosis and the detection method should be faster and more accurate, and also it is easy to be implemented in the experiment. The main stage of the main aim of the fault tolerance is to keep the converter continue its operation after the fault. Okay. This slide shows a studied converter based on the series resonant DC-DC converter. In the front end stage, it comprised of the full bridge inverter, and then cascaded with an isolation transformer with terminal ratio N. Here it is the transformer is a step up transformer, and then cascaded with the resonant tank, which includes the resonant cap CR and the resonant inductor L external, and also the leakage inductor of the transformer could be considered as a part of the resonant inductor, and the output side is the well-known full bridge bit on the diode. During this study, the series resonant converter will operate at fixed switching frequency at the DCX mode. This topology feature the galvanic isolation, and also it has the feature of soft switching at low electromagnetic interference. The aim of this study is to focus on the short circuit fault at the output side diode of the rectifier of the series resonant converter. When dealing with the fault tolerance of the bar converter, it is important to select a diagnosed signal that has a lot of information about the converter operation in the normal state and the faulty state. Also, it should be low cost solution and easy to implement. Here we propose to use resonant inductor voltage. This could be achieved by inserting a few turns into the resonant inductor core without affecting the main operation of the core, and the corresponding output voltage will be increase with the shorts when the short circuit fault occur in the output side, as the resonance current will increase. Here is a slide to reduce the proposed fault detection method. The signature signal based on the inductor voltage, resonant inductor voltage, is rectified based on fully bridge rectifier, and then it filtered with the RC filter, and then rectified signal will compared with a critical voltage, which could be defined based on the circuit operation. The output of the comparator is the signal S, which has two cases. When S is low, at the condition of the rectified voltage inductor voltage signature below the critical voltage, it is represents the normal or healthy state of the converter. On the other hand, when the rectified inductive voltage resonant inductive voltage signal is larger than the critical or threshold signal, it the signal is will be high, and the converter in this case will be in the faulty state. This is a general flowchart for the fault detection method. The algorithm always check the fault if there a fault detection or no. If no, it will continue, and if there a fault was detected, it will go to into the next stage, which includes the reconfiguration of the converter or fault tolerance of the converter. The aim of this stage is to keep the converter to continue its operation post the fault occurrence. Because when the short circuit fault occur at the opposite rectifier, for example at D2, the opposite rectifier will be similar to the well-known voltage doubler, and so the total gain of the converter will be double. So to keep the converter have the same gain before the fault case, we propose to reconfigure the input side full bridge into half bridge configuration. This could be achieved by turn on the switch S4 and turn off the switch S3, while the two switches S1 and S2 are driven by the pulse width modulation. By this methodology, the total gain of the converter will be the same. The simulation result was done based on the BCM software, and the parasitic element of the component of the converter are included during simulation, and also the target output voltage was 315, and the converter during this case operate at a fixed switching at 95 kilohertz. The first case of simulation was done at the light load condition, where at the light load conditions the resonant inductor current is small, and also the voltage of the resonant capacitor is small. The voltage was occur at 0.04 second. We can see here that the proposed detection algorithm can detect the fault within less one switching period, and we can see the output voltage remain constant, similar to the case before the fault occurrence, and also the average voltage of the resonant capacitor is larger than zero, because the output side operates as a voltage doubler, while before the fault occurrence it is average equal to zero. The second case of the simulation was done at full load condition at 200 watt of the converter, and we can see here that the resonant inductor current is larger compared to the previous case, and also the voltage of the resonant cap is large. Also the fault was occurred at 0.04 second, and we can see the proposed detection method detects the fault in less than one switching period, and also the voltage remain constant during the post the fault occurrence. Conclusion and the future work of the paper. The paper represents a method to detect the short circuit fault in the output side rectifier based on diode of the series resonant converter. The diagnosed signal was selected based on the resonant inductor voltage, which is considered a low cost solution and easy to be implement. The proposed detection method can detect the fault in less than one switching period, and the future work of this paper will consider the experimental validation of the proposed methodology. Thank you for your attention and welcome to any question.